So Arlene, yes, thank you very much for that kind introduction. I think it was agreed that I would be going first. And I'll be talking about the Galloway et al. Paper that was published earlier this year. Mark Strynar is a co-author, and it came out of Dr. Linda Weaver's laboratory at Ohio State University. And it's about our discovery of HFPODA, or Gen X, at the Chemours Washington Works facility in Parkersburg, West Virginia. And you probably know about this facility because it's arguably one of the most famous and most important as far as PFAS research is concerned around the world, because of the class action lawsuit that Rob Alott brought. And it's unfortunate that he's not able to join us today. But that lawsuit brought about the C8 Science Panel studies that eventually led to the declaration that Pfoa exposure leads to or is associated with 6 human diseases. And that includes kidney cancer, testicular cancer, ulcerative colitis, thyroid conditions, high cholesterol, and pregnancy-induced hypertension. So that's the reason why that's become very prominent. And I like to look at this and dwell on this because it's one of the best examples of how our regulatory process has gotten bogged down or overwhelmed. And it ultimately allows for the production and the use and emission of persistent toxic materials into the environment. And this happens over and over again, as you will hear as Mark and John give their presentations as well. So DuPont, early on, the first maintainer of the site, was using PFOA as a processing aid for the production of Teflon from 1951 to 2013. And during that time, they had extensive emissions to the Ohio River and to the airshed with very wide and broad sweeping accumulation in the environment. By about 2013, EPA had persuaded the 6 major companies or 8 major companies in the US to stop producing and using long chain materials. So PFOA was one of these long chain materials. And under the terms of the Stewardship Agreement, DuPont made the decision to change to HFPODA, which is hexafluoropropylene oxide dimer acid, or Gen X. They filed for a pre-manufacturing notice in 2009, which is the official notice to EPA that they would like to make this switch and start using this compound. It's required by TSCA. And as part of this filing, they noted that there was toxicity in laboratory animals, and it was very similar to PFOA. It included liver toxicity and cancers in the liver, pancreas, and testicles. So it was very much the same kind of class of compound and class of toxicity as well. So EPA noted in their approval, ultimate approval, that these findings were troubling, but they went ahead anyway with the approval for the substitution of PFOA with Gen X. And they began using it as their processing aid for the production of Teflon there in Parkersburg. Quite a bit came about as a result of Mark Strynar's publication of his 2015 paper, where he identified HFPODA and a whole series of polyether compounds in the Cape Fear River in North Carolina. And Jason Galloway, an Ohio State student, read about this and actually read about it in The Intercept and was very intrigued and came to us and said, isn't there something we could do together to investigate what might be happening in the Parkersburg area, because there could be other chemicals there. He eventually mounted a study pretty much on his own, where he collected 94 surface water samples and 13 soil samples, mainly upstream and downwind of the plant in Parkersburg. A lot of this took place in Ohio. And as a result, he found PFOA was detected in every surface water sample that he collected as far as 45 kilometers away from the site, with concentrations exceeding 1,000 nanograms per liter at 13 sample sites within 8 kilometers of the plant. So just astounding levels of PFOA concentration still many years after they stopped using the material, which were, undoubtedly affecting exposures to people and the environment. He also found HFPODA, or the Gen X, was widespread around the plant. It too was emitted by airborne sources and carried downwind. The highest levels that he found were above 100 nanograms per liter in surface water up to 6.4 kilometers away from the plant. And we have every indication that the material is accumulated in the soils and is percolating down into the groundwater at this time to affect future groundwater supplies. So I think this is a really good example that should be examined because it shows that EPA is approving and granting the use and allowing for the accumulation of persistent and toxic materials by industry and affecting human exposures in at least this part of the world. So Mark is going to be talking.
Thank you.
Mark is going to be talking about North Carolina now.
Yes, thanks, Andy. And it's a nice lead-in because all of this ends up being interconnected. So the story in North Carolina starts with a publication that Andy and I were co-authors on with Shoji Nakayama, where we did an assessment of perfluorinated chemicals in the Cape Fear River. You can read that paper to see more details, but one of the take-homes in that paper was at a tributary to the Cape Fear River, actually it turns out to be the DuPont effluent stream, was going in. Of all the analytes we measured for, had the highest concentration of any PFAS we were looking at the time, happens to be the C7 molecule. We anticipated it was still coming from that facility years later, but we didn't go back for a very long time. In the interim of publishing that paper, we had a correspondence responding to that paper from a gentleman named John Heinze, where he was representing the Fluoropolymer Products Information Center. And he made the point, in short, the surface water concentrations of PFOA in the Cape Fear River reported in Nakayama et al., his third point, are hundreds to thousands of times lower than the lowest benchmark or safe dose from risk characterization for human exposure. We were finding concentrations of around 40 nanograms per liter or higher in approximately 1/3 of the sites. Now, we were looking at surface water, not drinking water, but studies were showing at the time that your surface water intake concentration was essentially reflecting finished drinking water if you did nothing to scrub that water. Andy already mentioned about the PFOA Stewardship Agreement, and part of the agreement from these 8 major manufacturers was to divest from these C8 compounds, PFAS and PFOA, and to invest in other compounds, many of which we were not made aware of, something Arlene has talked about before, the question of regrettable substitution. And part of that problem is that in the pre-manufacture notice, that information is confidential business information, that though it may be shared with my organization, the EPA, it is not shared with me. A game changer in our lab was the acquisition of high-resolution mass spectrometry. Andy worked closely with Agilent Corporation to get a TOF system into our lab. It brought the ability for us to detect molecular weights to the 4th decimal place, where we could then take that molecular weight and predict a formula, and with a high degree of certainty, predict what that structure may be from that formula. This was certainly something that changed the game for us because we went from doing just targeted analysis, which we had done a lot of, to non-targeted screening, trying to find new things. Around this time in 2011 or so, we had not been back to the DuPont facility to take any samples since Nakayama. Our own inquisitive nature took us out there to find out, well, what can we find in the water? As it turns out, many things, many large peaks had this negative mass defect, which are indicative of polyfluorinated compounds. We had a very difficult time identifying what they are. It takes a lot of time and a lot of chemists' brains and work. As it turns out, one of the things that we used was going on in West Virginia. There was a consent order that was given to the state of West Virginia. And in that, DuPont said, and this was the kicker for us, has developed patented technology for a new generation processing aid for the production of high-performance fluoropolymers using a new compound called the C3 dimer acid salt. It gave 2 CAS numbers, which if you don't know, that's the social security number for a chemical, purine as known as the new compound, and it has a sustainable solution, including a favorable toxicological profile and rapid bioelimination. So get beyond the propaganda portion of that. We needed simply the CAS number. I purchased that standard. We went out, we confirmed that one chemical in that waste stream, HFPO dimer acid, or Gen X, was present. We presented that at CTAC in Long Beach, California in 2012. After I finished giving that presentation, Bob Buck from DuPont at the time stood up and said, great environmental forensics, but we already told your agency this information. Not super useful to us because we're not privy to what's going on at CBI. And
1 minute.
PMN. Xinyan Wang published a paper in 2013 where he showed this compound along with many others. Subsequently, we went back to the facility in 2014 where it was changing hands between DuPont and Chemours. We identified, as Andy said, about 12 new polyfluorinated compounds and began working with Detlef Kanapi to see what was being found in the finished drinking water of Wilmington, North Carolina, about 70 miles downstream. Through the efforts of Sun et al., Detlef is a co-author on that, we published that these compounds were present in the finished drinking water. HFPO dimer acid, or Gen X, was one of them. Many other compounds were present. They appeared to be unremoved from traditional drinking water treatment. You don't have GAC and you don't have ion exchange. They go through unretained. And later on, that was shown in the Star, I forget the name of the journal that did it, the Star News in 2017, that compound had tainted the drinking water of the Cape Fear Public Utility Authority's drinking water. And our job and our life changed dramatically at that point. So the connection of the dots through from location and facility and follow-up work continues on to the work that John will now talk about in New Jersey. I'll pitch it to you, John.
Okay, I hope everybody can hear me. Good. I'm John Washington, and I work with the EPA and ORD along with Andy and Mark. You'll see from our talks here, a sort of a common theme amongst the ORD scientists is where we are asked many times to investigate sites and find chemicals that we were unaware were even in existence as non-regulators in the agency. I'm going to be speaking about New Jersey today. In 2017, New Jersey DEP and EPA Office of Research and Development entered into discussions regarding New Jersey's concerns regarding PFAS distribution in the state. And so as a result of those efforts, in late 2017, New Jersey collected soils, waters, and vegetations around the state of New Jersey, including downwind of two PFAS-related industries in the state, Solvay and Chemours. The water samples went to EPA's lab in RTP with Mark and James McCord and Andy. The soil and vegetation samples went to Athens, Georgia EPA lab, where I am, as well as others on the team I'll mention later. At both locations, we started extracting and analyzing for these compounds, and on all media, we found high levels of legacy PFAS. Partially as a consequence of that, in both labs, we went ahead with non-targeted high-resolution LC mass spectrometry to investigate what else might be there. Independently, at both locations, we found a set of compounds that are new to the environment of the United States, so far as we know, newly reported in the environment of the United States, so far as we know, chloro-perfluoro polyether carboxylates. And so, again, we found these independently in two different labs at two different locations, RTP, Athens, Georgia, different environmental media, different lab instrumentation, and different research teams arriving at the same tentative identification of these compounds. We were able to reference Xinyan Wang review paper in which he had identified the same set of compounds as Solvay's compound based on an application from Solvay to a European regulatory agency. In that publication, we didn't have any standards, so we semi-quantitated based on mass labeled internal standards, and we're able to approximate a concentration. when we plotted those concentrations for the soils on a map and contoured them, the contours literally formed a bullseye on Solvay. Taken all together, this was pretty compelling evidence to us that these were Solvay compounds we're detecting, and we were detecting them all around the state of New Jersey. In fact, every sample of soil in New Jersey that we had, including ones that were on the opposite end of the state and intended to be background, had at least 3 congeners of this family of polyethers in them. And we took an in-house sample from New Hampshire and analyzed that and found one of the congeners in there in the New Hampshire soil as well. So that's a dramatic deposition pattern for these compounds. A little lost in this science paper that we published on this regarding the soils is that we also went back and examined the legacy compounds and was able to develop a single fingerprint for the long chain perfluorocarboxylates that formed the dual bullseyes, one on Solvay, dominated by long odd carbon number chains, and another bullseye on Chemours, dominated by the even carbon number chains.
1 minute.
Thank you. This effort, as I mentioned, led to a paper on the soils in the journal Science. And more recently, James McCord first authored with the rest of us on these compounds in waters of New Jersey and the efficacy of granulated activated carbon on remediation, and that's in the S&T letters. Mary Davis here in Athens, Georgia, is continuing to look at these compounds and legacies, the accumulation and vegetation. And Marina Evich here in Athens, Georgia, is looking at the degradation of these compounds, these polyethers, under environmental conditions. And so a long history of, in terms of recent science research of findings, more recent research findings just coming out with James McCord's, and we're hoping to have some successful stuff in the future as well. Thanks.